Okay, so we're saying solutions. Alright, so we're saying find the acceleration of the object when time is 3 seconds. So we realize that 3 seconds is somewhere here, right? And at that point, the acceleration, we're talking about this acceleration, meaning it's the same here, it's the same there, it's the same there. So what we're going to do, since we don't have the value that corresponds to 3 seconds when it comes to velocity this side, so we're just considering the entire distance that we have, the entire acceleration for that part. So that's something that you have to understand. You say acceleration here is just the same. So I'm going to say acceleration is velocity final minus initial velocity over time taken. Alright? Now, we're coming from here and going that side. So you should understand to say your final velocity is the one that's big, Q24, minus the initial. By the way, so velocity and the speed is just one and the same thing. In the sense, they just differ in the sense that velocity is a vector quantity. Okay, so minus 4, and the distance for the entire journey was 5. So the entire journey, what we mean is for this part only. Okay, not reaching that side. So specifically here was just solving for this part. So here we're going to have 20 over 5, and this produces a 4 meters per square second. Alright, so this is what we get. So that's our correlation at t is equal to 3. So this is what you get. Okay, now let's see, let's create more space here. Let's see how we're going to come up with a solution for B. So B reads, given that the object decelerates at this rate, okay, 2 meters per square second, find the value of t. Right, so you have to understand to say deceleration, also known as retardation, is negative acceleration. Okay, negative acceleration. So we're going to say you multiply the entire formula of acceleration by negative. Okay, so what are you going to get if you multiply that by negative? So we're going to get positive u. So it will come in front, minus v over t. So this is a formula that we have to apply that side. Okay, now we're saying the rate, we already know it, it's 2. Okay, what is the initial velocity? We know it that the initial velocity is 24. The final, we know where it's ending there, obviously, the velocity was 0. Okay, and the time taken, we understand to say, we're saying we can even put x or 10 plus x, something like that, if you want to find it. So here there's a way you can say you want to get t directly, or you can get t indirectly. So there are two methods that we can basically use to get the solution to this. So we're saying initial velocity was 24 minus a 0 over, so where there's a t here, what I'm going to do is I'm going to put 10, because we have the 10 here, plus this portion here. So this portion that we're going to add will give us the final t, 10 plus x, okay? Or 10 plus t, since we're looking for this specifically for this value here, okay? Now that we have this expression, we can just simplify at this point. So what we're going to have is 24 is equal to 2t. You see now? So this 2 is multiplying with everything. You want to put them in brackets. So this is 24 now, which is equal to, this is giving us a 20 plus a 20 plus 2t, right? Then from here now a 20 will come this side and you remain with only a 4. Okay, so you're going to have like something like this. Then here you remain with a 4, like that, if you solve it properly like that. So when you divide by 2, you discover that the t is actually 2 seconds. Okay, now just follow my videos properly. I will explain on how you can also get this same answer but using another method. Okay, so the t there was 2. Okay, t was 2. Now, to get the final value there, we are going to say t final is going to be now. This 2 does not make sense in the sense that you have 10 there. So I say t is equal to 2 plus t. So t initial, I can even put this one to be t. In fact, x was better. X was better to use. So if we have to put x here, it means yeah, x was better. So that this is just a value of x. Now t becomes 12, like that. Hope this makes sense. Okay. So I'll also just solve this one using the other method. So let's go the other method. So I'm going to say this is as well what we just said, u minus v over t. Then here we have a 2 already, and we know to say here we can substitute. So initial was 24 minus a 0, and now we want to find the time taken. So t, you can put t directly here. Okay, let's see what we get. Okay, point t direct. Let's see what we are able to get here. So what we're going to get is 2t is equal to 24, and when you multiply, t is equal to 12. All right, so this is more direct. Okay, this one is also working. Yeah, this one is also working. But you appreciate that other method that I used earlier for some questions, of which I'm going to show you when we start dealing with those questions exactly. Okay, so let's see how we're going to solve the third part, which is happening to be the last part of this question. So I asked to find the average speed, and you know average speed is the total distance covered over total time taken. Total time taken. Okay? Now, this one, they are saying the total time taken that we have to use is 10 seconds. So we're calculating the speed up to this side, not at 10. So this examiner was actually lenient enough in the sense that even when you get this one wrong here, you are still able to get the third part correct. Okay? So this is what we're going to do. Okay, so we're considering only the part from here. Okay, now that this question is very clear, so you have to specify. So for us to be able to find the distance covered, we say you find the area under the graph. So area under the graph given. Now, which graph is it? Which graph we're talking about? It's not the entire graph. So we're talking from here, coming to here, and the final will be here. We'll not reach that side. And I even said to say, since we're not reaching the far end, this examiner was lenient enough. In the sense that even when you miss it here, you're able to score here. Alright? So here, we consider shapes. We find the areas of the shape. So there's this shape here and this shape here. So this is going to be a rectangle, and this is going to be a trapezium. Okay, so this is a trapezium. So a trapezium is made up of a rectangle and a triangle. Okay, so two formulas that you have to know. Very simple. So area there is going to be half A plus B height for the trapezium, which I can call section A1, okay, and A2 to make things simpler. Okay, area is equal to A1 So A1 plus A2. Make things easier. Plus the second one, area for the rectangle, which is just LB. So this is going to give us what now? Half. Which one is our A? The shortest distance, which is 4. Because you are considering the trapezium as this part to that part. So the longest distance there is 24. And the height will become this one now, from here to that side, which is a 5, plus LB. LB, are considering this rectangle here. This one in the middle here. So, which is a 10 minus a 5, we get a 5 and a 24 as well. So, we get a 24 and a 5. Alright? So, remember, people one, do it the smallest numbers possible. So, half here, and this is going to give us a 28 and a 5. So, before we even multiply here, we can reduce it then. So we can reduce this 28 to something like a 14, okay? 5 like that, okay? You have a 5. So from here now, you understand to say, we can actually factorize so that you have a 5 this side since it's common, then a 14 plus a 24, okay? Hope you are connecting. But you can as well do it directly like that, but it will take your time. So this one will give us 8 and the 3 there multiplied by 5. And this is going to give us 40 and then the 4. This one 15 plus 4 like that. So what are we calculating? We're calculating the area. So distance in what? Speed, so in meters. So 190 meters. How about the total time taken for this journey? It was just 10. So, therefore, average speed is equal to 190 meters over 10 seconds. Okay? So, this was going to be 19 meters per second as our answer. Okay? So, thank you so much for watching. Make sure you like, share, and comment on our videos. Peace.